Hello, calculus, and welcome to Chapter 9. This is multivariable calculus. So we're going to have 2 or 3 variables in one equation. We're going to do derivatives, integrals, figure out how to use those, and calculate different applications with them. I hope you enjoy it. So you should have 9.1 notes out. Your calculator will be needed, and let's go. All right, so we're going to evaluate a function of several variables. We're going to graph it on a plane. We're going to talk about a level curve, so we're going to change a 3D graph into a 2D graph and find the difference of the quotient, which that should sound very familiar because we've done that before with single variable. All right, an example of fxy, several variables. So we have f of xy, so our variables are x and y, and 4x squared plus 2xy plus 3y. When I say find 2 or 3, that literally means plug in 2 and 3 and find the answer. Nothing too extraordinarily. Right here, we cannot plug in 4, 0, because if you look here, y is in the denominator, and it's illegal to divide by 0, so this is undefined. So make sure you're watching that. The second part is our difference quotient. Now we have to know what we're doing the difference quotient of. So do I want to do, oops, sorry, let's put this back down. The difference quotient in respect to x or the difference quotient in respect to y. So when we're going through here, if I have f of xh, so right here my difference, sorry about that, is changing on the x. So since this is changing on the x, this is the difference of f of x. So right here, we have x plus h here and y here. We literally plug x plus h in for x, and y we leave alone, and we do our calculations here. Make sure you square this out correctly. That's x squared plus 2xh plus h squared. Don't forget. Then take that times your 4, distribute your 2, and you have your 3 over y. All of it, of course, is over h. You also subtract, so this is the f of x plus h comma y. That's a terrible h. And this part right here is your original function, x of y, so nothing new. So we have the x plus h here, the y here, we subtract the 2, we divide by h. This is our limits, like we've talked about before, which led to derivatives. So I bet you can guess where we're going next. All right, here, I want you to find the section with f of x plus h. So pause and do both explorers, please. So this time you're going to find, first of all, f of x plus h, comma y, minus f of xy all over h. So here, should get rid of that extra parenthesis in there. Maybe. So now we're going to plug in x plus h in for the h, or the x, plus 5 times your x plus h, still times your y, plus 4y, excuse me, minus your original, so minus the 3x squared, minus the 5xy, and minus the 4y. Of course, all of this is divided by h. So do your squaring and multiply by 3. So you should have 3x squared plus 6xh plus 3h squared plus 5x plus 5h. Don't forget your y's with both of those. Plus your 4y minus the 3x squared minus the 5xy minus the 4y. Still all divided by h. Here we notice that the 3x squareds cancel, the minus 5xy's cancel, and the 4y's cancel. Everything now has an h in it, so we can divide by h, giving us 6x plus 3h plus 5y. Final answer. I hope you did well. Here, I'm literally asking you to plug in 1, 2, 3. So you should have taken 4 times 1 times 3 minus 3 times 1 squared times 2 plus 2 times 3 squared. Type that in your calculator, and I'm pretty sure you got 24. All right. Doesn't seem like it's hard enough, does it? Let's just give it a second. Okay, next thing we're going to do is graph in three-dimensional space. Okay, when you're graphing three-dimensional, you have an X, Y, Z plane. I'm only graphing in the first quadrant right here, or that's all I've got graphed out. So the X comes towards you, the Y goes straight out, and the Z is up. So X down, Y to the right, Z straight up. So when I say -2, that's the X, 2 on the Y, 1 on the Z. So here, this point 1, 5, 4, that meant I went down 1 on the X, I go over 5 on the Y, and then from there I go over or up 4 on the Z. This one here, we only went on the X, so it's 6, 0, 0. Here, I am going to go 4 on the X, 7 on the Z, so I went 4 this way, 7 this way, 3 down. That's how we got to the -3. All right, try yours. Here's your X, here's your Y, it's terrible Z. So I'm going to go -2 on the X, so I'm going back 2 on the X. Then I'm going over 2 on the Y, so 1, 2 on the Y, so we've gone -2X, oh that is not staying, right here, that's 2 on the Y, and then 1 up on the Z. So you went -2, 2, 1, and there's your plotted point. We do have special graph paper for that. Shouldn't go too bad. All right, I want to graph a plane. So we're going to make it just a little harder, not a straight point anymore. Okay, to graph a plane, we usually do intercepts. So 2x plus y plus z equals 6. So to do intercepts, like I'm going to graph the x-intercept, you let the y and the z be 0. So if y and z are 0, you literally are left with 2x equals 6, so x equals 3. So we go down on our xyz plane, we go to 3, and we plug in our first point. Now we find y-intercept, so you let x and z be 0, so those two cancel out. Y equals 6. So on the y-axis, we go to 6, and we put our second dot. Same with the z, so we let the x and y be 0. Z again is 6. Now you just connect those dots, so you're drawing these lines here. Oh, terrible. And here. And then the shaded area, again, is only in the first octant, but that is okay. It's easier to see that way. All right, you have 4 of them, I think. 3 of them. All right, give them a shot and see how you do. So the first one, I want to find the x-intercept. So we let z equal 0, which means x equals 6. So we got a 6 on the x, and we put our first dot. Now we want to find the z-intercept. So I let x equal 0, which means z equals 6. So I go 6 on the z. And we put our dot. I think I'm on 6. All right, since there is no y, that means it's parallel to the y. So this is parallel to the y. So we draw in, that keeps disappearing. We draw in our line here, and then we go parallel to the y to get our plane. This will go on forever, actually in both directions, like this and like this. And this shaded area here is the plane we've just graphed. All right, x equals 3. Wonder what that looks like. I hope you got it. X equals 3, you were on the 3 line. You are parallel to the y and the x. So it went this way, and it goes literally straight up and down. So you are graphing this up and down plane. If you went straight here just on the x in the first octant, that would have been perfectly fine. Okay, y equals 2. So how's this guy going to go? And I hope you got it. Y equals 2. You are now parallel to the z here and the x here. Is that going to grow? Parallel to the z. There it goes. So now this, all right, so this goes on forever in both these directions. So if we draw that parallel sides, it helps us see this. And this is a plane that goes this direction on the y. All right, last one. Actually, probably the easiest to draw out of them all. So we want to find the x-intercept. You let y and z be 0, so x equals 6. So your first point is at 6. I think that's 6. I need to make these bigger. Now we need to find the y-intercept. So we let x and z be 0, which gives us 2y equals 6. So y equals 3. Second point. And then the z-intercept, where x and y are 0, giving us 3z equals 6. So z equals 2. Connect your 3 sides. And you're in that first octant, and you've got this little bitty triangle that you should be showing. I hope you did well. All right, let's look at some 3D shapes here. Doesn't look like fun, does it? I'm kind of agreeing with you. It's a little bit tricky. So what they're telling you is if we're on Z, and I want to flatten this down to the XY coordinates so I can see what this looks like on a flat plane, kind of like a map when you're looking at top-bottom topographical map. All right, so this point here corresponds to this point on the XY. And we're going to learn how to do that with Z. So let's go through and see what this looks like. We're going to graph Z equals x squared plus y squared. All right, first of all, you should recognize that x squared plus y squared is a circle. That's helpful if you kind of know what we're graphing here. So if we look at x equals 0 first, so if I let x equal 0, I've got y squared. Well, y squared is a parabola. So I'm going to graph right here, x equals 0. Y squared is a parabola on the y. So it goes down, it goes through 1, 1, just like everything else, and it goes up and down. So there's my y squared. Now we're going to let our y equals 0, so that means z equals x squared. So now we got a parabola on the x-axis, which looks like this blue one here. Right? We know that x squared plus y squared is a circle. So what this is actually doing is going all the way around. So we are connecting all of these. So if we connected all of these parabolas, this is how the circle is increasing in radius. So we got x squared plus y squared is 1, x squared plus y squared is 2. You're changing your values of z. And x squared plus y squared is 3. So your circles are 1, 2, and 3. All right, now, so this whole thing looks like this when we put it all together. It's a paraboloid is what it's called. Now, that's hard to draw. So we want to put this down to an XY plane. So what we do is we take these circles here and we just flatten them onto our plane and show what they look like and how they correspond to each other. So our first circle was 0, 0 with a radius of 1. So we go to 0, 0, radius of 1. Next circle is the square root of 2, and the next circle is the square root of 3. And these is this graph drawn to 2D. They're called traces. Let's see if we can figure one out. Now, we want to graph the level curves, or the traces, for z equals 0, 2, and 4. So that means I'm going to let z equal 0, z equal 2, and z equal 4. So we literally go here. We go 2y minus x squared equals 0. So this is the z equals 0 graph. We're going to solve, so we know 2y equals x squared. We're going to divide by 2. So y equals x squared over 2. All right, we should know that parabola is 0, 0 because it hasn't moved. And then x squared divided by 2, that means I take my original y. So usually it's 1, 1. So 1 times a half. And a half over here. Then our next point would have been 2, 4. So half of 4 is 2. And we graph those two. That's a good enough sketch for this parabola. So there's this one and this one. So that's z equals 0. Next you do z equals 2. So you have 2y minus x squared equals 2. Subtract your x squared. divide by 2. So y equals 1/2 x squared plus 1. So we know that that takes my original graph, which is the one we just graphed over here, with the exact same shape, and it moves it up 1. So we're going to go up 1 and move every one of these points up here up 1, because it's just a transformation. I missed that one terribly. And draw in our next curve. Okay, the next one we're going to graph is z equals 4. So you should go z equals 4. We're going to plug in. Oh, I ran out of room. So 2y minus x squared equals 4. We're going to add our y, our x, 2y equals x squared plus 4, divide by 2. Y equals 1/2 x squared plus 2. So we're taking our graph again and moving it up 2. So we're taking the blue graph, going up 2. This would stay, that would be awesome. And draw in this graph. So those are our leveling curves. So I'm taking my z graph as if I'm looking from the bottom, on the top, and I'm smashing it down into the xy graph. All right, I hope you did well. Okay, Cobb-Douglas is a production function. It tells you how hours and capital relate together. So X is the amount of labors in hours, Y is the amount of capital in units. So if I have this many people working, how much do I need to keep them busy? Okay, what is the production when 40 work hours and 10 units of capital are provided? By the way, I forgot to say, this function changes. It is not always 2/3 and 1/3. So it's whatever they give you. So if I want to know the production, I just literally plug in 40 and 10, and I get approximately 25 units of capital is what I will need. So let's go this way. Determine the relationship between the labor and the capital for production of 100 units. So that means I want Z to be 100. How do I solve this? So I solve for Y. So you divide by X is 2/3, and then to get rid of this, remember you cube it. So you must also cube this side. So this is the formula we get. 1,000,000 over x squared equals y. Well, we kind of know what that looks like, I hope. So we know x can't be 0. So we go over here and we are going to plug in. I'm hoping you remember that 1 over x squared is this right here. Since it can't be negative, it's only this side is where this came from. So now let's plug in some numbers. If we plug in 100 for x, we get 100 here. If we plug in 200, it gets smaller. And this is where this graph comes from. So this is how they relate. So if 40 work hours are available, how much capital is needed? We literally plug the 40 into here, and we solve. I'll need 625 units of capital to supply my 40 hours of labor. All right, same idea. This time, this is our Cobb function. I want to know for 27 units. We don't have to graph these. We just want to know if you can find the answer. So step 1 is you plug in the 27. Oh, it's your turn. I'm sorry. Pause and try this. Okay, you're solving for y. Okay, to get rid of the 3/4, you must take the 4/3 power. 4/3 of 27 is 81. 4/3 of x to the 1/4 is x cubed, or x to the 1/3, I'm sorry. Said that wrong. And that equals y. And that's all you have to do. This is my function that will tell me what kind of labor I need. All right, these are things you just have to recognize. So if you see an x squared plus a y squared equals your z, that's a paraboloid. If you have x, y, and z, it's going to close and become an ellipsoid. If you have subtraction, remember subtraction was a hyperbola, so this is a hyperbolic paraboloid. And when I have basically z squared is what this is, minus x squared plus y squared, or the x's and the y's, two of them are negative. This is a hyperboloid in two sheets that goes away from each other. It's very cool. You don't have to do anything other than recognize. So when I have x squared minus y squared, hyperbolic paraboloid. Okay, your turn. And I'm hoping you came up with hyperboloid in two sheets. Again, you do not have to graph. All right, good luck on your homework. Post questions if you have any.